Okay, this is lesson 3.1 and 3.2. So with 3.1, there's first a couple of words to know, vocabulary. Inferential statistics, this is to make inferences or generalization about a population. In other words, when you do a study, you're using a sample size of the overall population, and so according to the data that you collect, you're going to make inferences or beliefs or conclusions about the entire population based off of your sample. And so if you did a study on people within Window Rock or Dene College, people within Dene College who like Disneyland, and you could do that study using a group of people to find out who likes Disneyland, who doesn't, whatever it might be. And then according to the study, you find out that 20% of people interviewed like Disneyland. So you would then say 20% of the people at Dene College like Disneyland. Okay, so that's an inference. So inferential statistics. Now descriptive statistics, this is using the charts and the tables and stuff that we learned in chapter 2 to help us describe the data that we have, okay? So to understand the data. All right, now going on to 3.2, measures of central tendency. Measures of central tendency basically is the values at the center of the data set. Now, the most common and the one that is used and liked and has the best and most meaning for central tendency is mean. Mean is the same as saying average. Most of us are used to averages like batting average, grade point average, and that kind of stuff. So average is a common word for us, and it means mean. Okay, and basically what you're doing is you're adding up all the numbers and you are dividing by the amount of numbers there are, okay, to get the mean. This is generally the most important of all the numeric measurements, okay? Now here's some properties of mean. Mean varies less than other measures of central tendency. So there's the actual middle point is closer to reality than with other measures of central tendency. The mean uses all data points. But the problem is outliers throw off the center and make the mean less accurate. Okay, so an outlier meaning data that is too big or too small for the information, that throws off where the mean actually is. And if there's an outlier, mean is not the most effective way of finding the center point, okay, or the center of the information. Now the formula for mean is right here. This right here is a Greek symbol meaning sigma. It looks better right here. This is me drawing it nice. This is me not caring, okay? It means sum or the addition of. So what you're going to do is you're going to add. X means the individual data points, so you're going to take each individual data point and add them together, and then N stands for the number of data points in the sample, so the total number of data points. This X with a line over it, that means the sample mean, okay? So that means from your sample, that's the mean of the sample. Now, a couple of things we didn't point out. N, this is the number of people in the actual population, so the actual number. And this right here is another Greek symbol called mu, and that is the population mean. So you're going to see mean with an X with a line over it, meaning that's from a sample, and you're going to see mean with this symbol with the mu, and that means the actual population mean, the actual, okay? So anyway, we're going to go over how to find mean here in just a minute. Another measure of central tendency is median. Median is the middle value. So what we do is we take all the numbers, we put them in order from least to greatest, and we get the middle number. Now sometimes, guys, there's going to be two middle numbers. If there are two middle numbers, we are going to add the two numbers together and divide by 2, and that will tell us what the median is. I will be showing you that in just a minute. Mode is another form of measure of central tendency, And this is the number that occurs most often. So if you have 2 2s and 3 5s, 3 5s would be the mode. Now you can have more than one mode. For example, you can have 2 modes, you can have 4 modes, you can have as many modes that are necessary, and you can have no modes, which means no number repeats. If it's 2 modes, that's called bimodal. If it's more than 2, it's called multimodal. Multimodal. It's kind of a hard word. Multimodal. Say that 3 times fast. Anyway, so those are measures of central tendency, okay? Now, those are the 3 most common, and let me kind of tell you when you're going to use them. Mean is what you use when there's no outliers. Okay, it's the most accurate. You want to use it anytime you can. Median is what you'll use when you can't use the mean because of an outlier. Okay, so median is more accurate in that case if there's an outlier. And mode is usually something that you'll use for non-numerical data, like for example people's favorite jeans. Levi's, I don't even know what other kind of jeans there are. Anyway, you would find out which one occurs the most often, and so you would be looking at mode. I'll give you an example of this in just a minute, but I also want to talk about mid-range. Mid-range, or as it's often just referred to as range, is basically taking the maximum value, adding the minimum value, and then dividing by 2, and that gives you the middle of the numbers, more or less. Now the problem with that is it's very sensitive to the minimum and maximum values. In other words, if those minimum and maximum values are outliers, that's going to affect the center point as well. But what it does do is it does help define the center, okay? Kind of helps see that your center is somewhere around this area, okay? Be careful not to confuse it with median, because median use calculations that are similar, but it is different. Now, let's go ahead and try one of these. In the book, it talks about counting the chocolate chips in Chips Ahoy cookies, okay? So I'm just going to write what data we have. There were 22 in one, 22 in another. There were 26, 24, and 23. Okay? And those were the amount of chocolate chips counted within 5 different chocolate chip cookies. Now, to find the mean, what we're going to do is we're going to take all these numbers and add them together. When I add them, I get 117. So 22 plus 22 plus 26 plus 24 plus 23 is 117. And then we're going to divide by the amount of numbers there are. There are 5 numbers here, so we divide by 5. When we actually divide those, we get 23.4, which means the mean is about 23.4 chocolate chips per cookie. Okay, now does that seem kind of in the middle of this information? 22, 23, it's just barely above 23, and then we have 24, 26. 23 is right about the center, isn't it? And so that is the most accurate measure of central tendency. Okay, now median. Let's just say we throw on there 27. Now I'm going to take this 27 off in a minute, but let's just throw one more in there so I can show you what to do in this case when we have an even amount of numbers. But median tells us to arrange them in order from least to greatest. So 22, 22, next is 23, 24, 26, and then 27. So now they're in order from least to greatest. And I want the middle number, so I'm going to start canceling. Let's see, cancel one off from each end, another one off from each end. Oh, I'm stuck with 2 middle numbers. Now, if we kept it in this order, or we would have had to rewrite this order too without the 27, but that one would have a defined middle number, and so we wouldn't. Every time you have an odd number of numbers, you're going to see an exact number there. Anytime you share 2, we're going to add them together, 23 plus 24, and divide it by 2. So 23 plus 24 divided by 2 is 23.5. Pretty dang close to each other, aren't they? So they're measures of central tendency. Now the mode in this case, and we'll go back to the original one here, the mode is the only one that occurs more than once, and that would be 22. So our mode is just 22. Now let's just say I had 26 on here. Well then my mode would be 22 and 26. Now let's say I had another 26. My mode would no longer be 22 because that one only occurs twice, and 26 would now occur 3 times. You guys get how mode kind of works? It's the one that occurs the most often, and anything that's tied gets to be mentioned. It's kind of nice that way, right? You get to be included as long as you can tie. Alright, so mean, median, and mode. Now let's do the mid-range. Now the mid-range, we're going to leave off that 27. The mid-range, we take the largest number, which was 26, and add the smallest number, which was 22, and divide by 2. When we do that, we get 48 divided by 2, which would be 24. This validates those measures of central tendency is really kind of what it does. I mean, it's not the greatest calculation, but we had 23.4 and 23.5. This one says 24. It pretty much shows that we are somewhere around the center of the data that we have, okay? All right, and mid-range is really easy to compute, so that's something nice about it. Now, calculating the mean from frequency distribution. There's a formula for it. The mean is x with a line over it, right? That means mean. And it's the sum, that's my sigma, remember that's my lazy sigma, of f times x divided by the sum of f. Okay, so f stands for the frequency, and x is going to be our class midpoint, okay, in this case. So here's how this works. You remember the IQ one. With the IQ we had 50 to 69, 70 to 89, 90 to 109, 110 to 129, 130 to 149. Okay, so that was our IQ. And our frequency, that was 2, 33, 35, 7, and 1. And so now we're just going to find the class midpoint. Now the midpoint, guys, is this. 50 plus 69 divided by 2. Okay? 50 plus 69 divided by 2. And that's a 69. And that equals 59.5. And then I would do 70 plus 89 divided by 2. 90 plus 109 divided by 2. And that would give me all my class midpoints. Class meaning the class. Each one of these is a class. And then the midpoint of the class, adding the two numbers together and dividing by 2 to find the middle. So this one was 59.5. When I add 70 and 89 and I divide it by 2, I get 79.5. Here we'll get 99.5. And we'll get 119.5. And then the last one is 139.5. Okay, so those are my class midpoints. Now if I'm following this formula, what it tells me to do is up here I'm going to take the sum after I multiply these together. So this is my f down here, my frequency, and this is my x, my class midpoint. I'm going to multiply these two numbers together to give me f of x. So f times x, sorry, not f of x. F times x. When I multiply 2 times 59.5, I get 119. Multiply here, I get 2,623.5. This one is 3,482.5. This one's 836.5, and this one is 139.5. Now, because I want the sum of these multiplied, here's them multiplied. Now the sum is when I add these all together. When I add those all together, I get 7201. Down here, this is the sum of all the f's. So I add these together, which we did earlier, and we got 78. Now, let's finish solving this. This right here is the sum of f times x. That's what that is. So that goes on top. 7,201 over the sum of f, that's the sum of f right here, 78. We divide those and we get 92.3. And that is how we calculate the mean of the frequency distribution. Okay? The mean of the frequency distribution. Now weighted. Calculating weighted mean. Okay, we're going to recognize some things within this formula as well. Nice thing is, guys, if you needed to pause the video, you could pause it and look at that again and rewatch it and do whatever you need to do so I can keep moving along. Okay, weighted mean. The mean is x with a line over it. It's the sum of the weight times the x value divided by the sum of the weight. Pretty similar to what we were just doing. So listen closely to this example. W will stand for the weight. X will stand for the amount of credits in this case, okay? So in the first semester of college, a student received final grades of A for 3 credits, A for 4 credits, B for 3 credits, C for 3 credits, and F for 1 credit. The grading system assigned quantity points. A equals 4 points, B equals 3, C equals 2, D equals 1, and F equals 0 points. Okay, now this is how we find our GPA. So what we need to do is we need to multiply all of our W's times X's, right? Our weighted value times our actual. So since we had an A with 3 credits, that's my X, and A is my weight of 4, we're going to add together 4 times 3. So the weight 4 times the amount of credits was 3. That was our first A. Our next A is 4 credits. So we're going to add to that 4 times 4. The weight, 4 points for an A, 4 credits. Okay, next we had 3 credits, a B for 3 credits. So a B is worth 3 points, and it was 3 credits. Then we had a C for 3 credits. A C is worth 2 points, but it was 3 credits. And then we had an F for 1 credit. Well, I'm going to erase this now. An F for 1 credit would be a 0 times 1, right? Because it was weighted at 0 and it has 1 credit worth. Alright, so when we solve this, we want this all over the sum of all of the weights. 4 plus 4 plus 3 plus 2. We want it for all the weights. All these ones, sorry. So 3 plus 4 plus 3 plus 3 plus 1. Okay? Sorry, W is for the credits. I totally messed you up on that. And X is for the weights. This formula will still work out, okay? It's all the same stuff. Anyway, when we solve this, we get 43 over 14, and that equals 3.07. Okay, so let me do this one more time. This was the amount of credits, right? So the amount of credits was W. That's what we're making W. X, that stands for the weight. So I mixed those up a little bit. But anyway, the formula ends up being the same, and your GPA is 3.07. Okay? All right. And that is it for 3.2.